Here we have two limits at infinity to evaluate. Actually, it's the same function, just one is the limit as x goes to infinity, and then part B is the limit as x goes to negative infinity. But for A, we just have the limit as x goes to infinity of the quantity 40x to the fourth plus x squared plus 5x all over the square root of the quantity 64x to the eighth plus x to the sixth. Okay, well, the same key we've been using holds true here. It says to divide everything by the largest power in the denominator. So in this situation, let's look at our denominator. Looks like our largest power, and this just applies to the x term. So we have x to the eighth, but it's really square root of x to the eighth. So in this case, what I'm going to do, how we interpret this key, is we'll divide everything by square root of x to the eighth. So there's the denominator, and then up here in the numerator, square root of x to the eighth, square root of x to the eighth, etc. Except for one thing. It's not going to do us much good to divide by square root of x to the eighth in the numerator. So let's take a closer look at square root of x to the eighth. Square root of x to the eighth is really x to the fourth. But even that's being a little sloppy. Technically, it's absolute value of x to the fourth. But since we're raising this to an even power, 4, this is simply x to the fourth. Why does that matter? Well, it will matter as we take x to negative infinity. We have to start thinking about this absolute value. Why is it absolute value of x? Where did that come from? Well, remember that the square root of x squared is absolute value of x. So we need to be real careful when we start working with these square roots of even powers of x. It doesn't matter in this video, but I want to mention it because it will matter in future videos. Okay, so up top we'll divide everything by x to the fourth over x to the fourth over x to the fourth. Okay, well, now in the denominator we can combine all of this under the same radical. So what does this give us? We still have the limit as x goes to infinity. That's still hanging out. Let's see, up top we just have 40 plus x, make that 1 over x squared, plus 5 over x cubed. And then down below we have the square root of 64, x to the eighth and x to the eighth cancel out, and then x to the sixth divided by x to the eighth gives us plus 1 over x squared. Now when we go to evaluate this limit, anything with just x hanging out in the denominator will go to 0. So that term drops out, 1 over x squared goes to 0, 5 over x cubed goes to 0, and 1 over x squared goes to 0. That is evaluating the limit, so we don't need to write the limit anymore, and we just have 40 over, well, square root of 64, which is 8, which is 5. Now let's take a look at part B. We now have the limit as x goes to negative infinity of the same thing, 40x to the fourth plus x squared plus 5x, all over rad 64x to the eighth plus x to the sixth. Okay, we use the same technique. Divide by the largest power in the denominator, so down below we have the square root of x to the eighth, and up above we're dividing everything by x to the fourth. But I actually just left out a lot of subtle points there that I want to bring up. Turns out in this problem it doesn't matter at all, but in other exercises it will matter. So let's take a really close look at what's happening here. Square root of x to the eighth can be thought of as square root of x squared to the fourth. Square root of x squared, all raised to the power of 4. Right? That's the same thing here. Those are the properties of exponents. Well, the square root of x squared is the same thing as absolute value of x. So we have absolute value of x to the fourth. Well, here we need to use the definition of absolute value of x that's commonly used in calculus. The absolute value of x equals x whenever x is greater than or equal to 0, but it equals negative x whenever x is less than 0. And this bottom case is the case that we use whenever we're letting x go to negative infinity. So to even be a little bit more clear, if you're evaluating the limit as x goes to negative infinity of some function, replace the absolute value of x with negative x in that function. Now again, this doesn't matter for this particular example. Why doesn't it matter? Well, because what we have then, this was absolute value of x to the fourth, but now we know we replace that with negative x to the fourth, but when we're raising it to the power of 4, we're just back to x again because negative raised to an even power is positive. So what we did up here was completely legit in this case, but it won't always be. So I wanted to slow down and take a really close look at that, because there are examples when you have to change the sign of x when you take the limit as x goes to negative infinity. Okay, well, we know how to proceed from here. The limit as x goes to negative infinity then is simply 40 over square root of 64, which we already decided was 5. So that one happens to be the same limit in both directions. Let's finish out by taking a quick look at the graph of this function, just to ensure that indeed that limit is 5 in both directions. So here's the graph of the function in Desmos, and you can see this limit as x goes to infinity is 5, and as x goes to negative infinity is also 5.